Hello dear students, welcome to my YouTube channel. Today we are going to learn MCQs related with magnetism. In the earlier video, we have seen the theory of magnetism. Now let us study the MCQs related with magnetism. So first MCQ, which of the following is not a property of a bar magnet? We have seen that a bar magnet attracts iron, nickel, steel. It always rests in north-south direction. Like poles repel and unlike poles attract each other. So all these are the properties of bar magnet. But option D, like poles attract and unlike poles repel each other. This is not the property of a bar magnet. Magnetic intensity we know that magnetic intensity is a vector quantity. It requires both magnitude as well as direction for its measurement. Which of the following is not a property of magnetic lines of force? We have seen that magnetic lines of force starts from north pole and ends at south pole. Magnetic lines of force never intersect each other. Magnetic lines of force forms a closed loop, and magnetic lines of force are not affected by non-magnetic material. So option C, are affected by non-magnetic material. This is not a property of magnetic lines of force. Magnetic flux density is dash proportional to the magnetic field intensity. We have seen that magnetic field intensity increases, then magnetic flux density also increases. So B is directly proportional to H. The direction of a magnetic field within a magnet. Now the difference between electric lines of force and magnetic lines of force, it comes in this option. Electric lines of force starts from positive charge and ends at negative charge. Similarly, magnetic lines of force starts from north pole and ends at south pole externally, that is outside the magnet. But within a magnet, inside a magnet, it starts from south pole and ends at north pole. So from south to north. When the north poles of two bar magnets are brought close together, there will be. So we have seen that like poles repel each other while unlike poles attract each other. Here given two north poles. So between two north poles, there will be a force of repulsion. The unit of magnetic flux density is known as. So magnetic flux density, its unit is Weber per meter square, which is also called as Tesla. The energy resides in a current carrying conductor in the form of. So whenever a current carrying conductor is given, then around itself a magnetic field is generated. So energy resides in current carrying conductor in the form of magnetic field. The attractive power of a bar magnet is at. We have seen that magnetic field strength, it is maximum at the ends, that is at the poles, and zero at the middle. So attractive power of a bar magnet is at ends, that is at poles. A magnetic compass is used to measure. So whenever a bar magnet is freely suspended, it always shows a north-south direction. And that's why a magnetic compass is used to measure direction. The force of repulsion between two magnetic poles depends on. We have seen from Coulomb's law of magnetism, the force of attraction or repulsion, it is directly proportional to strength of two poles and inversely proportional to square of distance between two poles. Also we say that it also depends upon the medium in which the two poles are kept here. So the option here, it is all of the above. Which of the following is a magnetic material? So magnetic material means which can be attracted by a magnet. So iron, cobalt, nickel, all these are the materials which can be attracted by a magnet. So these are magnetic materials. So all of the above. If a magnet is broken into two equal pieces, the pole strength of each half will be. Whenever a magnet is broken into two equal pieces, then each piece will have a south pole as well as a north pole. So its strength or pole strength, it will remain same. Magnetism at the center of the bar magnet is. We have seen that the strength of magnetic field, it is maximum at the ends, that is at the poles, and it is zero at the middle. So at the center of the bar magnet, magnetism will be equal to 0. The space outside the magnet where its pole has a force of attraction or repulsion is called as. So space around the magnet in which force of attraction or repulsion is present, it is simply called as magnetic field. A substance that attracts pieces of iron, it is simply called as magnet. The total number of magnetic lines of force in a magnetic field, it is called as magnetic flux. The force acting on unit north pole placed at that point is called as. So every magnet, it has a certain space around itself which is called as magnetic field, and the strength of this magnetic field, it is simply called as magnetic field intensity. The unit of magnetic flux density, we know that unit of magnetic flux density, it is Weber per meter square, which is also called as Tesla. So both options A and B are correct. The region around a magnet or current carrying conductor in which its magnetic effects can be observed is called as. So this is the simple definition of magnetic field. The intensity of magnetic field at a point is defined as the force experienced by dash dash kept at that point. So in electrostatics, we consider unit positive charge, that is a charge of +1 coulomb. In magnetism, we consider unit north pole. The magnetic lines of force moves outside the magnet. So outside the magnet, externally, the magnetic lines of force moves from north pole to south pole. The magnetic lines of force moves inside the magnet. Externally, we have seen that magnetic lines of force moves from north pole to south pole, but inside the magnet, it moves from south pole to north pole. And that's why magnetic lines of force forms a closed continuous loop. The magnetic lines of force starts from dash dash poles and ends at dash dash pole outside the magnet. So starts from north pole and ends at south pole outside the magnet. So option will be north south. Magnetic lines of force dash dash intersect each other. So we have seen that to find out the direction of magnetic field at any point, we draw a tangent to the electric lines of force at that point, and it has different directions at different points, and that's why magnetic lines of force never intersect each other. Magnetic lines of force contract. So magnetic lines of contract in length, that is longitudinally. Magnetic lines of force expand laterally. The magnetic lines of force are unaffected by dash dash material. So magnetic lines of force have no effect on non-magnetic materials like paper, wood, plastic, etc. The magnetic lines of force of non-uniform field are. So if the magnetic field, it is non-uniform, then magnetic lines of force will be curved in nature. The magnetic lines of force are crowded in a region where the magnetic field is. We have seen that the strength of magnetic field, if it is large, then magnetic lines of force are crowded. So here magnetic field will be large. The magnetic lines of force are separated in a region where the magnetic field is. So magnetic lines of force are separated. This means that these are less crowded and these are less crowded when magnetic field strength, it is small. When a bar magnet is suspended freely in air, it always points towards dash dash direction. We have seen that if a bar magnet is suspended freely, as in case of magnetic compass or compass needle, then it always shows north-south direction. And that's why magnetic compass, it is used to measure direction or to find direction. Weber is the unit of. We have seen that Weber, it is the unit of magnetic pole strength. Also, it is the unit for magnetic flux. So both options A and C are correct here. The north pole of one magnet will dash dash of another magnet. So north pole, if two north poles are given, there will be force of repulsion. So we say that the north pole of one magnet will be repelled by another north pole. So it will be attracted towards the south pole of the another magnet. The property, important property we consider here, that is like poles repel each other, whereas unlike poles attract each other. So north pole of one magnet will be attracted to the south pole of another magnet. Thank you very much. If you like this video, you can like and subscribe to my YouTube channel. Thank you very much.